So what is IEEE? We are just an institute of engineers, and we pretty much dedicate our lives to engineering, to making tools and improving the way we live our lives. And what does IEEE do? What does IEEE actually do? The group itself, it's a national society. You can find IEEE in all the universities. They have clubs and societies all around. And it's a great way to network. It's you meet all of the other students and professionals in your field. Is anybody here? Let me see some hands. Who wants to become an engineer? Who's actually going to follow engineering? All right, pretty good amount. All right, so yeah, it's a great way to network. Most engineers will know what IEEE is, if you ask. And IEEE is also a great way to get yourself involved at the university. You know, I didn't know any of my professors on a personal basis until I actually joined IEEE and started planning events with them. Can everybody hear me back there? Yeah. All right, just making sure. And it's also a great way to research and stay informed. IEEE has these publications every month or so that will keep you informed on what are people doing, what are people researching. So it's a great way to stay ahead and stay very involved in your field. So can anybody tell me what an engineer is?
Someone.
You, my friend. I couldn't have said that better, my friend. Engineer is somebody that makes things better and makes things new, and that's actually very true. It's an engineer is any person who uses scientific method and mathematics to improve tools or to make new tools and to just improve our lives as is.
Yeah.
We're not very aware of the engineers that make our stuff. But there are engineers behind everything that we use. Most of you guys have phones. There are engineers working on that. Everything that you see around you, engineers help create, make, or improve. So I got some examples here of very successful engineers that I'm pretty sure everybody knows them. Everybody knows this logo? Obviously, Ford. Before it was a giant company, it was a man named Henry Ford, and he was an engineer. And he devoted his life to improving cars. And because of his actions, because of his work, we all know his name now. And yeah, it's a giant company. That's another one, Adobe. Has everybody seen this symbol around? Mm-hmm. Everybody's very familiar with his work. It's and yeah, Adobe is, he again devoted his life to making an improvement. And he improved sound quality, and he did the surround sound system. Then it's really the only way that we can watch Twilight series. It's surround sound. So he really helped us out there. And another famous engineer is Bose. Anybody ever heard of Bose systems? Yeah, they're very good sound system. Again, those are all last names of actual engineers that helped create or start these companies. They all started with a dream. They wanted to improve something, and now we all know who they are because of it. And up there I got a picture of the Wright brothers, who were also engineers, and as we all know, they created airplanes before they existed. And there were no airplanes before the Wright brothers. So that's another engineer at work there. And we got a lot of different types of engineering. Engineering is a big umbrella that covers a lot of different fields. We got chemical engineers. Chemical engineers, they create things like shampoo, like bleach, and all the different chemicals that we use on a daily basis. We got electrical engineering, and that's what I'm studying myself, and so is Naval here. We're both studying electrical engineering. And that has to do with power, generation, transmission, and also electronics. It's the other end of electrical engineering is the applications of electricity. So computers, iPhones, anything that you can think of electronics. You guys familiar with Xbox at all? Exactly, engineers help create that. And we got computer science engineering. They do a lot of programming. Again, Xbox, there were plenty of electrical, plenty of computer engineers behind the creation of a such system like an Xbox. Civil engineering, those are the engineers that help create buildings, roads, buildings such as this one. Yeah. It's all civil engineers that do that. And we got mechanical engineers. Those are more guided towards anything that moves. Anything you can think of that moves mechanically, a mechanical engineer help do that. Got some examples here of the different types of engineering. So again, it's not just electronics, it's not just buildings, it's everything. Everything that we use, everything that we do, engineers can help improve. So I like to focus a little more on electrical engineering because that's obviously the one that I'm a little more familiar with. It's what I'm studying, and I love the field. It's quite fascinating. So electrical engineers, we use the power of electricity to make the world a better place. It goes from creating electricity to power plants to transmission again, and the other hand with electronics, and very exciting stuff. So it's very broad as well. And I got a picture here of how it actually works. It's just generation of electricity. There's a few different ways, I'm sure most of you are aware. Transmission, distribution, and then we're watching TVs out. So again, how the whole system works is we create energy in some form. We know it's usually heat that gets transferred into energy, and we create a signal out of this generation. And that signal gets transmitted into our homes, and we get to use that with all of our beloved toys. So any of the in-betweens there, electrical engineers, you can help research, you can help improve, and any improvement that you can do, you can call yourself a successful engineer. So how does electricity work? Can anybody tell me how electricity works? That's actually really, really good. These are smart ones. So, electricity, we create electricity, we create energy through wind, we create energy through heat, which is nuclear fusion, and we transfer that energy through electricity. And energy is simply the ability to do work. And energy is not just electricity, though. When you think of energy, it's a much broader term. For example, we use energy from food to move around, and it's almost the same kind of energy that we're producing when we're producing electricity. It's a little different, but it's basically the same concept. And sail boats use wind as well to move, so and that's all different examples of energy. So electrical engineers, we concentrate a lot into waves and communication. So when you get to the algebra classes and you're dealing with sine waves and stuff, don't get scared because it's very, very important for most of the engineering field when it comes to calculus. And when you're dealing with waves, it's very, very important to keep up with. So we use waves to communicate with all different kinds of electronic devices. All of these, the phones, when you're using your phones, there's so many complex waves coming in and out of the phone that it has to be understood by somebody to put it all together so we can all use. So that's where all the algebra and calculus comes in. You gotta pay very close attention. We got some more examples, satellites, Wi-Fi, a little clicker that I'm using. The RC stuff, it's all different kinds of waves that we transmit and we receive. And in order to do that, we have to fully understand what we're transmitting and receiving. And so I got some more examples here. The RC stuff and the phone, and we got the one RC thing up there that didn't work. Waves didn't quite work out for us. That's what that meant. So again, to go over waves, it's the way we transfer energy in a way, and that's how energy gets transmitted. It's through waves. When you guys gone over waves yet? In class and what it does? Because I don't want to bore you with all this this technical stuff. But frequency is just how fast the wave is actually traveling. If you got a slow wave, it's a slower frequency, obviously. And amplitude is how high the signal actually goes back and forth. So and this is just the start of it all. It gets a lot more complex, but it's very, very fascinating stuff. It ever fascinates you guys how we can talk on the phone with somebody across the world and it's live? That's how fast waves travel. It's quite a fascinating subject. And again, thanks to most electrical computer engineers, but it's mostly engineers working on all of it, and we all get to use it and improve our lives with it. So I got an example here of waves that I can actually show the amplitude and frequency and how it actually. The theremin here is an instrument that uses those radio waves to play a sound. So in a way, it translates the waves to a sound, so you can actually tell the frequency, not really tell, but you can see the difference between a high frequency, a low frequency, a high amplitude, and a low amplitude. So Naval here is going to... His right hand is changing the amplitude. So when it's a very low sign, it's so low that we can't hear it. So when he raises that amplitude, it becomes a much higher sound, so we can hear it. His left hand is doing the frequency. The closer it is, the higher frequency. That's why we can hear a higher pitch. We got an oscilloscope here that can actually tell you the wave that's and how waves create. And believe it or not, most of these waves are actually very complex sine waves. So that's why we learn about those waves, because they are the basis of everything as far as all the studies that we do with them. And yeah, this is a fun little instrument. Let's give a round of applause to they use theremins to make sounds for movies, like Star Wars sound, all kind of sci-fi movies. Sometimes you'll hear wah wah wah, and that's where it comes from. It's a theremin. So we also got a couple of lasers coming out. We got a laser show, and can anybody tell me what a laser is? That was good. It's a beam of light produced by an energy source, and that's right on. This is what it stands for. You're very welcome. Good job. It stands for light amplification by stimulated emission of radiation. And that's just a very weird term for saying exactly what she said. It's a light produced by a source. And we got an awesome laser show coming up for you guys, so you can see what it looks like. Yeah. And we are just now figuring out different ways of using lasers, again, to improve our lives. In the next couple of years, you'll see flexible screens on phones and stuff like that, and it's all, again, engineers working hard to find different applications for all this technology that is created. So engineering is fascinating. So what is EEE again? It's a collection of engineers. It's the way that we get to talk to each other and network. And we manipulate energy and waves for the advancement of technology. So what does that mean for all of us here? With those signals, it's toys, technology, and stuff that improves our lives. And soon enough, Iron Man will become a reality. Don't take my word for it. And these are the guys that help us put it together. Hobbytown USA, a one-stop laser shop. Does anybody have any question before we start the laser show? Glad to